So welcome to another module, module 4 of C# programming and understanding foundationally what it takes to start being an engineer, developer, software, web developer, whatnot. I am Professor Francis Fiske. If you are watching me, you've made it this far, please like and subscribe. That'll really go a long ways to promoting this content to those who need it the most. Either way, let's go ahead and get started. Today, we're going to discuss, lecture on looping. So what are loops? Well, loops are what we call in computer science iterative statements. They are statements which allow us to loop over programming statements. So you can think of it like a data structure, which allows repeated execution of a block of statements, especially if you want to do it in repetition sequentially. Normally, your loop body is what fires, as long as a specific looping sentinel value is of a specific Boolean, right? So for instance, as long as something is true, keep looping. Hey, I want you to stop looping at this specific point when this is true. I want you to do something and then loop. Or I want you to do something and then check that Boolean expression for a sentinel value that I want. And as long as that's true, we're going to continue looping until it isn't. Now, your loop body normally has all the programming statements that you are, most interested in repeating over and over again. And there's different types of loops. Now, when I say the word type, I don't mean data types. I mean actual data structure types, right? So you have the loop as the generic idea, right? And then you have the loops. You have while loops, which loop while a Boolean expression is true. You have a do while loop, which does something first, and then it checks the Boolean expression to see if it's true. You have a for loop, which contains 3 elements: your counter, your condition, your Boolean expression that you need to check, and your iterator, which is what increments or decrements or executes, or whatever the case may be, your counter within your for loop. And then you have your programming statements, which loop until your condition is true. You have for each, or your condition is false. I apologize. So for instance, in this case, if you look at the for condition, I is greater than array.length right here. If you look at that Boolean expression, it's going to loop as long as I is less than array.length. The same is true the other way around. And we'll go over this in the code. I may be saying this backwards, but we'll go over this in the code in later modules to get more context. And then you have your for each. Your for each loop is a wrapper around your for loop. Basically does the function of the for loop, the event-driven iterations of the for loop, but instead of you having to supply a condition, a counter, and an iterator, what the for each loop does is it traverses through each of the nodes in a collection. It looks at all the items in a list, all the positions in the array that are being filled, and it asks itself a singular question. Am I done yet? Have I reached the end of this collection? And once I reach the end of that collection, it stops on its own. For loops don't do that, and you can get gnarly errors when you don't take into consideration how big something is. If you iterate through a box, let's say you have a box of dice, and you need to count all the dice in the box. Well, your computer, for most of the time, needs to know when to stop, right? How would you know when to stop? Well, if it's in a specific data structure like an array or a list, you can tell it, well, this is how big that thing is. So go until you reach this number, which is what this length property is doing. It's a property, and it exists for all arrays. List collections are a type of array, right? Array lists and whatnot. If you were taking Java and lists themselves in C#. And what the length property does is it tells us how big, how many positions exist in a sequential data structure, like an array, a list, other collections like dictionaries, hash tables, things like that. Well, your for each loop doesn't care about that. You won't get a out of index exception, because that's the name of the exception, out of index exception, when you try to iterate over a data structure like an array and you ask the array for a position which doesn't exist, right? So if you're iterating over the array and it only has 6 items in it, 6 positions are filled, and then you say, hey, I want what's in the 7th position, right? Then I want what's in the, I believe it's the 8th position. I'm saying this incorrectly. I want what's in the 8th position, right? Because you count from 0 or 6th position, whatever. I want what's in the next position. If that position doesn't exist in that data structure, in that array, the computer's going to throw an error and stop. It's going to throw a catastrophic error and stop. It will not keep processing. And if it's a web page, you're going to have to refresh to get that page to do something again. So you want to avoid that specific error because that's a catastrophic error out of index exception. It's also an exception that is logical in nature. And when I say logic, we haven't spoken about debugging, but you have what's called syntactical errors. These are errors that your program catches, right, on its own. And so when you try to compile, it'll tell you can't compile because object not referenced to an instance of an object, or you can't write it that way because the computer's not going to understand what you're trying to do. But there are other errors which are harder to find and more of a nuisance, especially because it can impact user acceptance through user experience. Those are called logical errors. You're not out of index exception. The array position you're asking for doesn't exist. That is a logic error. You will not get that. That will not get caught at the compile, because when you compile your code, it's looking at the way you wrote your code and asking a set of statements to itself. Will this code be able to run? Yes, great. But just because your code is able to run doesn't mean your code doesn't need some left and right guardrails to make sure that your user doesn't experience a catastrophic error. So one of those things is when you have an array, you want to iterate over the array until you reach the amount of positions that array has. Now, for a list, the for each loop delays this problem because it stops on its own. You don't have to tell it. This is how big the collection is. One of the drawbacks about using a for each loop is you don't have a counter. So if you wanted to index that collection with the position that you're at, you would have to create a counter outside of the for each loop and then use it within, and that's a waste of resources. If you're going to do that, you might as well just use a for loop and iterate over it like we do in the old school. For all intents and purposes, a for loop is faster than a for each loop, but it's negligible. It's so negligible that we use for each loops like crazy. The last loop I want to talk about is recursion. So recursion is a form of looping that is not a loop itself, and it is not iterative. It can be iterative if you use jump statements and like, but in most situations, it is not iterative, which means you're basically executing that method until a condition is met. Normally, we do recursion when we want to restate a prompt to a user or an issue to a user, and we use recursion in situations where we need that method to run again in the event that an error has occurred. So within the context of that out of index exception, you can actually catch that exception and you can tell the method to run again and try again, right? We call this retrials. That's the technical term, but that's not what is written into the code. If you want to do a retry, you'll do a recursion. And what recursion is you write a method that does the things. We haven't spoken about methods, but in this case, I need to bring it up and we'll go over recursion. I'll show you what that looks like as well. Recursion is you write a method or a function. In this case, it's going to be a method. That method does things, but somewhere along the line in the code that the method is running, it runs into a problem or it asks itself a Boolean expression. At that point, you can tell the method, hey, if you run into this specific event, this specific use case, this specific happy path, unhappy path, then you need to run that method all over again. Now, you might be asking, when in the hell would I ever do that? And when I first heard about recursion 20 some odd years ago, I asked the same question. But recursion is actually very powerful because with recursion, what you can actually do is you can make things that seem insurmountable easier to ingest. So in today's day and age, you might not write a logger, but let's use a logger as an example. So in development and programming, we like logging events, like logging tasks and logging errors. We want to know what's going on in our program, and logging is the easiest way to do that. Logging is the action of taking a common language, almost like pseudocode, and you're putting it into another file, like a text file, a database, or a central repository that holds logs to see what's going on in your program and to be able to attack errors faster, right? Logs are integral for this. Now, if you're trying to write a log entry, or any entry for that matter, to a file, your file will have to be locked because you can't have two different writers or stream writers open on the same object. Like, it's just not possible. We found a way to make it parallel, but anyway, it's still not possible, right? Not from a programmatical C# 9 and below perspective. So with that being said, what you're going to need to do is write a recursive method that says log something. And it's going to try to log to the file. If it gets an error back from the file is locked. You'll catch that error. You're going to wait a second. You can tell the program timer.wait or whatever, just wait. and then try to log it again. So you'll execute that log method all over again. It'll try to log it again. If it can't log it because the file is locked for whatever reason, it'll catch it. It'll hold it for a second and it'll try it again. Now, this is a situation where you have a program, right, which is like an enterprise level application that might be logging to the same location from many different places. Those many different places can't log at the same time, and you don't want to look through all these other files. So what you want to do is you actually want to tell the file, well, you're going to log for the person that's logging in, that's writing on you, and then you're going to unlock when that's finished. While you're locked, you'll throw errors until the next thing can log itself to the logger. Hopefully that makes sense. That was a real world explanation of why we would use recursion. Now, up to this point, we've discussed only iterative statements, and we're going to go deep into the weeds on each one individually in the upcoming modules. But what I want to really stress and bring and run home to you are jump statements. So loops are iterative statements. They're statements which iterate until they don't iterate anymore, until we tell them to stop, or they stop on their own. That's the difference between a for loop or a for each or a while or a do while. But there's also jump statements. Now, jump statements are statements that allow us to do some really gnarly things when we want to create a program that has exit conditions or conditions where we don't really need to keep running the loop or the iteration of the loop. So a jump statement unconditionally transfers control within the context of the stack trace. All right. The stack trace is the sequential nature in which your code runs: line 1, line 2, line 3, line 4, line 5. Now, the stack trace starts to get really complicated when you start introducing methods, because you will write a method. Okay, now the stack trace is executing that method. So now it's got to go to the methods program and start at the methods line 1, line 2, line 3, line 4, line 5. If the method then calls another method, then the program then has to step over in the stack trace and do the same thing again for the next method and go back to the place it stopped at the last ladder. Now, why is that important? Well, in a loop, there are certain situations when we want to use jump statements to jump the stack, to jump to a part in the stack and not sequentially go where it will go on its own. What do I mean by that? Well, let's say you have a loop that you want to stop. Okay, you want a loop that you want to stop. You don't want it to iterate anymore. Stop right now. Let's say you're looking at a collection and you're trying to find something and you found it. You found what you were looking for in that collection. You are going to tell that looping algorithm to stop. Don't loop through this collection anymore. It is in the collection. So now I'm going to do something else, right? If you want to do that, you will use the word break by itself on one line. Now, remember, break is very powerful. Break actually stops the array, or I'm sorry, stops the loop. Any loop, any iterative statement. The next jump statement you need to be aware of and cognizant of is continue. So while break stops all looping whatsoever and moves to the next part of the code, so you're in a loop, you're in a loop, you're in a loop, you say break, that loop will stop right there at the break, and the stack trace will jump down and not loop anymore to the next line in the programming statements. Continue does a little bit of the same at a more specific level. Continue means I want you to stop this iteration. I do not want to continue down these programming statements in this iteration of the loop. I want you to jump out and go to the next iteration. Now, this might be true if you find values that, let's say you're looking through a collection and you want to filter it, and you don't want to use the .filter method you produced by link, which would be much easier, or I'm sorry, .contains, not .filter, or do a lambda expression, which is a little more complicated. You're like, you know what? I just want to check this collection for something, and then if it's in the collection, keep it. If it's not, get rid of it, right? And when I say in the collection, I mean it is a valid value that's in the collection. Maybe all the only values that you accept are 1, 2, 3, 4, and 5. You have a collection that has all kinds of numbers, and you're saying, okay, well, you know what? If 1, 2, 3, 4, or 5 is the number I run across in each iteration, continue, right? Don't do anything. Those are supposed to be inside this collection array. However, if you run into something, right, that doesn't belong here, it's not 1, 2, 3, 4, 5, then I want you to delete it. Now, the word continue can be put above that delete statement in an if branch. And you can say, if, item equals or item contains these values, then continue, meaning go to the next iteration. We don't want to do anything with it. And then underneath that if statement, if the if is false, meaning the if returns and says, no, this doesn't belong inside the array, then the next thing is delete, and then the loop will actually reiterate on its own. There are two other jump statements, but they don't necessarily correlate too strongly to iteration, right? Break and continue are jump statements that we use in iterative loops or iterative statements all the time. There are two other statements that don't necessarily align with usability in a iterative statement, but I want to bring them up anyway. The first one's return. So what return does is it actually does the same thing that break does, but it does it for a method. So let's say you're writing a method. Up to this point, you've probably seen methods where there's only one return at the bottom that returns a value because the program did some things. But as you progress and advance in your capacity as a software engineer, software developer, you will find that the return statement is actually used prolifically by senior and leads and architects on a regular basis because they give us an opportunity to create event-driven code where we can have exit conditions along the way. Now, why is that important? Well, I don't want to run code. I don't want code to run needlessly, right? So let's say I had an exit condition as we've been talking about. Let's say we have a method, and the exit condition of that method is that the response you got back was the response you're looking for. Either it's a 200, okay, everything's great. It did work, great. Okay, let's say you don't get that response. Let's say you get a response that's not okay. Well, you can return and you can say, well, I don't want you to keep running whatever is after this because the okay is what I'm looking for to continue, right? Not use the word continue, but to continue. And if I don't get that, then just return what the error is and move on to the next thing. Don't even run whatever's underneath it. There are situations where return is very powerful. And remember, return has to return a value. It can't just, okay, return back to this place. It has to return a value. So a string, an integer, and we're going to go over return in great detail when we get to methods. And then there's a go-to. And go-to is normally used when you mark and label your code. So you can go back to a specific place. That's good and imperative for you. Look, I really enjoy all these lectures. Doing these micro lectures, again, get me, very close to the actual meat and potatoes of C# and is exciting me all over again. So like and subscribe if you haven't already. And as I say in all my videos, good luck, have fun, ciao.